Activities such as walking to running, playing high-intensity sports like basketball or football, to just chilling on the couch and watching TV. What these activities all have in common is that they require us to breathe. But why do we have to breathe? Everybody knows that if we don't get enough oxygen, we die. But most people don't know how the oxygen is used. The complicated mechanism that forces us to breathe is respiration. The process of respiration is similar to charging a phone, except instead of taking in electricity, we need glucose and oxygen. The first step of respiration is glycolysis. The word glycolysis comes from glyco, relating to the 6-carbon molecule glucose, the simple form of sugar found in carbohydrates, and lysis, meaning breakdown or disintegration. The main purpose of glycolysis is to create more ATP. ATP is short for adenosine triphosphate, the molecule that is similar to the currency for the body. The body uses ATP for anything requiring energy. The ATP molecule has a 5-carbon group and 3 phosphate groups, shown on the left. Energy is released when the outermost phosphate group is broken through hydrolysis. Glycolysis has many complicated steps, but most important to learn is that ATP and NADH is generated, and we end up with a molecule called pyruvate. The pyruvates from the earlier slide help start the citric acid cycle. Similarly to glycolysis, the citric acid cycle has many minute and complicated steps. The primary products are ATP, FADH2, and NADH. At the end of glycolysis and the citric acid cycle, only 4 molecules of ATP are created, which is not very nearly enough for a cell. The secret to respiration is oxidative phosphorylation. During oxidative phosphorylation, an enzyme called ATP synthase uses the FADH2 and NADH molecules to convert ATP into ATP. Oxygen comes into play when ATP synthase releases electrons that have to be excited by the oxygen for us to breathe.